In the unending quiet of the solar system's outer dark, a silent vigil is kept by sentinels of silicon and steel. They are humanity's tireless eyes, our automated watchtowers peering into the void for whispers of motion and hints of light. Their names are ATLAS, the Asteroid Terrestrial Impact Last Alert System. Scattered across the globe, they conduct an endless robotic ballet scanning the celestial tapestry night after night after night. Their mission is one of premonition of cataloguing the wanderers. They trace the paths of asteroids and comets, the forgotten debris left over from the solar system's chaotic birth. Most of what they find is routine, a faint smudge of light moving against the stellar backdrop, its destiny, a predictable arc governed by the immutable laws of gravity. And so it was for a faint traveller designated C, 2025 T1 Atlas. It was just another discovery, a ghost in the machine. A loose conglomeration of ice, dust, and primordial rock, perhaps no more than a few kilometers across on its first journey inward from the unimaginable distances of the Oort cloud. For months it behaved exactly as expected, a point of light following a mathematically perfect yet utterly unremarkable path. It was a phantom on a schedule, a cosmic footnote in the grand encyclopedias of astronomical data. Astronomers logged its position, calculated its trajectory, and turned their attention to more pressing celestial matters. This particular celestial iceberg was of little consequence. It was too faint, too distant, too predictable. No one was watching it with any particular intensity. No one expected what was about to happen. Then, in a single, unobserved moment, in the cold vacuum of space, the unremarkable became the extraordinary. Without a sound, without a witness, C, 2025 T1 Atlas detonated. It wasn't an explosion in the terrestrial sense, no fire, no shockwave. It was an eruption of pure, silent, radiant energy, a catastrophic blossoming of light and matter. The automated systems of Atlas programmed for consistency were the first to register the profound violation of the norm. An algorithm designed to notice subtle changes in brightness screamed a digital alert across a network of servers. A faint object previously catalogued at a dim 18th magnitude had suddenly impossibly brightened by a factor of thousands. A human astronomer, likely roused from sleep by the urgent notification, would have stared at the preliminary data with profound disbelief. It had to be an error, a sensor flaw, a cosmic ray hitting the detector, but the anomaly persisted. Follow-up observations were hastily scheduled. Across the planet, colossal telescopes stirred from their slumber, their immense domes parting like eyelids opening to a new reality. They swiveled their colossal structures, focusing their giant mirrors on that one specific, unassuming coordinate in the constellation Perseus. The data that streamed back was not an error. It was a revelation, a spectacle of cosmic violence and beauty. Where a tiny frozen nucleus had once been, there now existed a vast ethereal sphere of glowing gas and dust. A ghostly nebula, a phantom planet, had been born in the void. It was a cloud of its own vaporized essence, expanding outwards at tremendous velocity, energized and illuminated by the distant Sunday. Measurements were taken, calculations run and rerun. The numbers that emerged were staggering, defying all expectation. The glowing Coma, the atmosphere of this shattered celestial body, had swollen to an almost inconceivable size. It stretched 400,000 kilometers from edge to edge. This is a dimension that strains the human imagination. It is a distance greater than that which separates the Earth from its moon. You could fit more than 30 planet Earths side by side within the shimmering confines of this newly formed ghost. A solitary, insignificant chunk of ice had in an instant metamorphosed into a structure of planetary proportions. It was an outburst no one saw coming, an event that would rewrite our understanding of these enigmatic visitors from the cosmic deep. The silent wanderer had found its voice, and it was screaming light. To truly grasp the significance of this celestial eruption, we must journey back, far back into our own history. For millennia, humanity has looked up at the night sky and seen these apparitions as messengers, as omens. Long before we knew what they were, we knew that they were different. Unlike the serene and predictable march of the planets and stars, these visitors were transient, wild, and utterly unpredictable. They were the hairy stars, the cometae of the ancient Greeks' celestial spectres that would blaze across the heavens for weeks, then vanish as mysteriously as they had arrived. Their appearance was almost always linked to profound events on Earth. They were thought to be portents of war, the death of kings, of famine. In the year 1066, a brilliant traveller we now call Halley's Comet appeared in the skies above England. It was seen as a terrifying omen, immortalised in the threads of the Bayeux tapestry as a sign of the impending Norman conquest. For cultures across the globe, from the emperors of China to the skywatchers of the Mayan civilization, the sudden arrival of a comet was a disruption of the divine order, a celestial announcement that the world was about to change. These objects were not thought to be part of the heavens proper. The heavens, according to Aristotle and the philosophers who followed him, were a realm of perfection, of immutable crystalline spheres, where planets and stars moved in perfect eternal circles. These chaotic, ephemeral comets could not belong to such a place. They must therefore be atmospheric phenomena, fiery exhalations from the Earth itself rising into the upper air, closer to us than the Moon, a form of strange weather. This misconception, this fundamental error in our cosmic address, persisted for nearly 2,000 years, a testament to the power of philosophical tradition over direct observation. The spell was finally broken in the late 16th century by a Danish nobleman with a prosthetic nose made of brass and an unquenchable thirst for data. His name was Tycho Brahe, an astronomer of immense skill and ego. When a great comet appeared in 1577, Tycho was ready. From his magnificent observatory on the island of Hven, he used instruments of unprecedented precision to measure its position. Crucially, he compared his own measurements with those taken by other astronomers across Europe at the very same time. He was searching for parallax, the slight shift in an object's apparent position when viewed from two different locations. You can see this effect yourself by holding a finger in front of your face and closing one eye then the other. Your finger appears to jump. The closer the object, the more it jumps. Tycho reasoned that if the comet were a nearby atmospheric event, it would show a significant parallax appearing in different spots against the background stars for different observers. But his meticulous calculations revealed something astounding. The comet showed no discernible parallax at all. This could mean only one thing: it was incredibly far away. It was at the very least farther away than the Moon. With this single powerful piece of evidence, Tycho shattered the crystal spheres. He proved that the heavens were not immutable and that comets were true celestial objects journeying through the realm of the planets. The next great leap came from a contemporary of Isaac Newton, the brilliant and dogged astronomer Edmond Halley. Armed with Newton's revolutionary new theory of universal gravitation, Halley embarked on a monumental task. He gathered all the historical records of cometary appearances he could find. He painstakingly calculated the orbital paths for 24 of them. As he pored over his tables of numbers, a pattern began to emerge. He noticed that the comets of 1531, 1607, and 1682 all followed remarkably similar paths through the solar system. A breathtaking idea formed in his mind. These were not three separate comets. They were a single object returning again and again, trapped in a vast elliptical orbit around the Sunday. He made a bold public prediction: the comet would return. It would reappear, he proclaimed, in the year 1758. Halley did not live to see his prophecy fulfilled, but on Christmas night of that very year, an amateur German astronomer spotted the faint familiar glow. It was back right on schedule. In that moment, comets were transformed forever. They were no longer supernatural omens or divine messengers. They were physical objects, members of our solar system, their journeys dictated not by fate but by the elegant laws of gravity. They were a clockwork part of the cosmic machinery. But what times were times they for centuries their physical nature remained a mystery. It wasn't until the mid-20th century that a cohesive picture emerged, proposed by the American astronomer Fred Whipple. He envisioned them not as gravel banks or solid rocks, but as something stranger. He called them dirty snowballs. This simple, elegant model has proven to be remarkably accurate. Imagine a relic, a time capsule from the very birth of our solar system forged 4.6 billion years ago in the swirling protoplanetary disk. It is not made of clean terrestrial snow. Its ice is a bizarre cocktail of frozen water, carbon dioxide, ammonia, methane, and carbon monoxide. Mixed into this cosmic ice cream are specks of dust, silicates, and complex carbon-based organic molecules. This primordial rubble was too far from the nascent sun to form a planet. It remained frozen, pristine, and unchanged in the deep freeze of space. These celestial bodies reside in two great reservoirs at the solar system's edge. The closer is the Kuiper Belt, a flattened disk of icy worlds beyond the orbit of Neptune, the home of Pluto. But beyond this lies a far grander, more mysterious realm, the Oort cloud. It is not a cloud in any conventional sense. It is a theoretical gargantuan sphere of unimaginable size, encasing the entire solar system like a vast, fragile shell. It may begin thousands of times farther from the sun than the Earth, and extend perhaps a quarter of the way to the nearest star. Within this colossal sphere, trillions of cometary nuclei drift in a slow, silent dance, barely tethered by the sun's fading gravitational grip. They have been there since the beginning, silent witnesses to all of cosmic history. For billions upon billions of years, a body like C, 2025 T1 Atlas, would have floated in this perfect absolute cold. Then something happens, a subtle disturbance. The gravitational nudge from a passing star, a galactic tide, or a close encounter with another Oort cloud object. This tiny perturbation is enough to disrupt its eons-long slumber. It is kicked out of its stable, distant path and begins a new journey, a journey of falling. For millions of years it plummets inwards, a slow-motion fall from the frontiers of the solar system towards the distant beckoning Sunday. As it crosses the orbit of Neptune, then Uranus and Saturn, it is still a dead, frozen world. But as it continues its descent, approaching the orbit of Jupiter, something magical begins to happen. The Sun, once a brilliant but distant star, now becomes a source of palpable heat. Its warmth begins to touch the surface of the nucleus for the first time in 4.5 billion years. The ancient ices, which can only exist in a solid state in extreme cold, begin to react to this newfound energy. They don't melt into a liquid. In the vacuum of space, they sublimate. They transform directly from a solid into a gas. Jets of vapor burst from the nucleus's surface like cosmic geysers. These jets are not just gas. They carry with them the dust and grit that was locked within the ice. This expanding shroud of gas and dust forms the comet's atmosphere, its coma. It is this coma reflecting sunlight that makes the comet visible to us. As the comet gets closer to the sun, this process accelerates. The solar wind, a constant stream of charged particles from the sun, pushes the gas away, forming a straight, glowing blue ion tail. Sunlight itself exerts a gentle pressure on the dust particles, pushing them back into a broader, more gracefully curved dust tail. The dirty snowball has awoken, transforming into the beautiful ephemeral spectacle that has captivated humanity for ages. But this awakening is also a process of self-destruction. With every pass around the sun, a comet sheds a layer of its substance, bleeding its very essence into the vacuum of space, until eventually there is nothing left but a dark, inert husk of rock, or it disintegrates entirely. This is the normal life cycle of a comet. A gradual, predictable brightening and fading. What happened to C, 2025 T1 Atlas, was not normal. It was not a gentle awakening. It was a convulsion, a catastrophic event that increased its brightness 10,000-fold in a matter of hours. So, what could have caused such a violent, spectacular outburst? Scientists are now piecing together the clues, exploring several dramatic possibilities for what happened in the dark. One of the leading hypotheses is a process best described as the cosmic champagne bottle effect. To understand this, we must think not of the comet's surface, but of its deep, unlit interior. Imagine a bottle of the finest champagne, not aged for decades, but left in the deepest, coldest freezer imaginable for 4 billion years. The liquid inside is frozen solid, but the dissolved carbon dioxide is still there, trapped within the icy matrix. Now, take that bottle and begin to warm it ever so gently. As the outer layers absorb heat, that warmth slowly penetrates inwards. Deep beneath the surface, the frozen carbon monoxide and nitrogen gases, far more volatile than water ice, begin to sublimate. They turn into pockets of high-pressure gas trapped beneath a thick, cold and brittle crust of water, ice and rock. The pressure builds and builds and builds over days or weeks. The comet's nucleus becomes a ticking time bomb. It is searching for a weak point, a fissure, a crack, a less consolidated area in its ancient frozen structure. Then the moment comes. The internal pressure overwhelms the tensile strength of the overlying crust. The seal breaks. In a single cataclysmic instant, the trapped superpressurized gas erupts with unimaginable force. It doesn't just vent, it blasts away tons of the overlying material, exposing vast new regions of pristine volatile ice to the direct heat of the Sunday. This triggers a runaway chain reaction. The newly exposed ices instantly sublimate, adding to the explosive force, releasing even more gas and dust into the expanding cloud. This is not a gentle geyser. It is the catastrophic failure of the entire container, a detonation that rips the heart out of the comet. The result is exactly what we observed, the sudden explosive formation of a gigantic coma, a 400,000 kilometer sphere of debris, all born from a single point of structural failure deep inside the nucleus. A second, even more dramatic possibility is complete structural failure. The cometary nucleus may not have just vented, it may have shattered. Comets are not solid monolithic rocks. They are fragile, porous aggregations of ice and dust, often described as having the consistency of poorly packed snow or styrofoam. They are held together by their own feeble gravity and the adhesive properties of their frozen gases. They are, in a word, fragile. As C 2025 T1 Atlas plunged towards the Sun, it was subjected to immense and competing forces. The Sun's thermal energy heated it unevenly, creating massive internal stresses between the hot day side and the frigid night side. The rapid sublimation of gases could have spun the nucleus faster and faster like an unbalanced spinning top until centrifugal forces literally tore it apart from the inside out. It may have split into 2 or a dozen or 100 large fragments. Each new fragment would expose a completely fresh surface area of ancient ice to the full, unrelenting power of the Sunday. What followed would be a cascade of sublimation, an exponential increase in the release of gas and dust as the entire broken body collectively vaporized into space. We wouldn't see the individual fragments from Earth, not at this distance. All we would see is their combined output, a sudden, brilliant and rapidly expanding cloud of light where a single point used to be. The comet in this scenario has effectively died, its solid form sacrificed in a final glorious flash of luminosity. There is another more subtle and fascinating explanation, one that involves a strange quirk of cosmic chemistry. It hinges on the very nature of the ice itself. When water freezes on Earth, its molecules arrange themselves into a neat, orderly hexagonal crystalline structure. This is crystalline ice. But in the ultra-cold, low-pressure environment of the outer solar system where comets are born, water can freeze differently. The molecules can become locked in place in a completely disordered, chaotic arrangement. This is known as amorphous ice. It is a less stable, higher-energy form of ice. Think of it like a compressed spring storing potential energy. As the comet warms on its journey inward, a critical temperature can be reached deep within its core. At this point, the amorphous ice can suddenly and spontaneously rearrange itself into the more stable, lower-energy crystalline form. This process, known as a phase transition, releases the stored energy. It releases heat. This sudden burst of internal heat deep within the comet's nucleus would act like a detonator. It would trigger the rapid sublimation of the more volatile gases trapped within the amorphous water ice like carbon monoxide. This could initiate the kind of runaway champagne bottle event we discussed earlier, but with an internal trigger. A kind of cryovolcanism, an eruption powered not by molten rock but by the restructuring of ancient exotic ice. It is a beautiful, elegant theory suggesting the comet contained the seeds of its own destruction locked away in its molecular structure for billions of years, waiting for just enough warmth to be unleashed. While the cause remains a subject of intense debate, the result is a gift to science. An unexpected, invaluable opportunity. This colossal cloud of gas and dust is not just a beautiful spectacle, it is a cosmic laboratory delivered to our doorstep. The explosion has done for us what no space mission could easily do. It has excavated the comet. It has blasted material from deep within the nucleus, primordial matter that has been shielded from solar radiation and cosmic rays for the entire age of the solar system. This is the raw stuff from which the planets were made. It is a sample of the solar nebula flash frozen and preserved, and now it is hanging in space, a translucent sphere begging for us to analyze it. And we have the perfect tools to do just that. The most powerful of these is spectroscopy. By attaching a spectrograph to a large telescope, astronomers can take the faint light from the comet's Coma and split it apart, much like a prism splits sunlight into a rainbow. But this cometary rainbow is special. It is crossed by a series of dark and bright lines, a unique barcode. Each chemical element and molecule absorbs and emits light at its own specific characteristic set of wavelengths. These lines are chemical fingerprints. By reading this cosmic barcode, astronomers can determine with incredible precision exactly what the expanding cloud is made of. They can measure the ratios of water to carbon dioxide. They can detect the telltale signatures of ammonia, methane, and more exotic compounds like cyanogen and hydrogen cyanide. They are, in essence, performing a chemical autopsy on the remains of a 4.6 billion-year-old entity from hundreds of millions of kilometers away. This is where the story of a single exploding comet connects to one of the deepest questions humanity has ever asked. Are we alone? The study of comets is inextricably linked to the field of astrobiology, the search for the origins and distribution of life in the universe. We now know that Earth in its early violent history was subjected to a period of intense bombardment by comets and asteroids. This late heavy bombardment delivered enormous quantities of water to our young, dry planet, filling the oceans. But what if they delivered more than just water? What if these dirty snowballs were also cargo ships carrying the essential organic ingredients required for life to begin? Space missions like the European Space Agency's landmark Rosetta mission to Comet 67P Churyumov-Gerasimenko have confirmed this suspicion. They found not just simple molecules but a rich soup of complex organics. They detected glycine, the simplest amino acid, a fundamental building block of proteins. They found phosphorus, a key component of DNA and cell membranes. They found the chemical precursors to sugars and lipids. In essence, they found that comets carry many of the key ingredients from the recipe of life. The cataclysmic outburst of C, 2025 T1 ATLAS, provides an unprecedented chance to expand this extraordinary inventory. Because the material has been dredged from the pristine interior, it offers a cleaner sample of the comet's original composition. Scientists are undoubtedly pointing our most powerful observatories towards this fading ghost. The James Webb Space Telescope, with its unparalleled sensitivity to the infrared light, where molecules vibrate and rotate, is the perfect instrument for this task. It can peer into the expanding cloud and search for the faint signatures of even more complex prebiotic molecules. Every new organic compound identified in the ejected material adds another piece to the puzzle of our own existence. It strengthens the hypothesis that the raw materials for life are not rare or unique to Earth, but are common throughout the cosmos, sewn into the very fabric of planetary systems by these icy wanderers. We are looking at the remnants of a cosmic delivery service, one that may have seeded countless worlds, including our own. In the ghostly glow of a dying comet, we catch a glimpse of the very chemistry that eventually led to us. What then is the ultimate fate of this celestial voyager? Its future is uncertain. If the nucleus shattered completely, its life as a singular object is over. Its fragments will continue along the same orbital path, but they will slowly drift apart, a string of cosmic pearls. The smaller pieces will sublimate away to nothing, while the larger ones may continue as tiny independent comets. The trail of dust it has left behind will persist, and perhaps one day, centuries from now, the Earth will pass through this debris stream and fragments of C, 2025 T1 ATLAS, will burn up in our atmosphere as a meteor shower, a final fleeting tribute to the comet that once was. If, however, a substantial part of the nucleus survived the blast, it will be a changed world. Scarred, pitted, and depleted, it will continue its journey. It will loop around the sun and begin its long, slow climb back out into the darkness from which it came. It will travel for hundreds of thousands, perhaps millions of years, before it reaches the apex of its orbit in the frigid abyss of the Oort cloud. Its violent story, a brief flash of light in the inner solar system, will be a distant memory. The explosion of C 2025 T1 Atlas is more than just a fascinating astronomical event. It is a profound cosmic lesson. It serves as a humbling reminder of the dynamic, violent, and unpredictable nature of the universe we inhabit. We build our models, we calculate our orbits, we believe we understand the clockwork of the heavens. And then, without warning, a quiet piece of that clockwork detonates, unleashing forces we are only just beginning to comprehend. An event that no one saw coming underscores the vastness of our own ignorance and the boundless capacity of the cosmos to surprise us. It shows us that the space between the planets is not empty. It is an active, evolving environment filled with ancient relics that can at any moment spring to spectacular life. These objects are not merely points of light or astronomical curiosities. They are our tangible connection to the dawn of our own world. They are messengers from a time before the Earth itself had fully formed. Within their frozen hearts, they carry the chemical memory of the cloud of gas and dust that gave birth to the sun, the Earth, and every living thing that has ever graced this planet. By studying their composition, by witnessing their spectacular violent transformations, we are engaging in a form of cosmic archaeology. We are sifting through the ruins of creation. The sudden 400,000 kilometer glow of this one distant comet illuminates not just a patch of the night sky, but the deepest, most profound questions of our own origins. It reminds us that the story of the universe is our story, and that its most ancient secrets are written in ice and dust, drifting silently through the dark.